We're back to do case 2 problem example 2, case 2. These are the answers I've already got listed. So that's where we're going to end up, I'm hoping. But here's the deal. In case 1, we said that mu k and mu s were 0. So we just wanted a frictionless surface. In case 2, we're now going to have some friction, and we want to figure out, all right, well, how much friction do I need, or what kind of coefficient of friction do I need to hold all this stuff in place? So our process is still the same as always. We're going to pick the 3 different systems we could study. So M1, M2, and then the M1 and M2 system, which you can draw as either a block and then a rope and an angle, or I think more people in this class now have started doing this and drawing it like that. Okay, so looking at our free body diagram, on M1 we'd have its weight, we'd have normal force, and we'd have tension pulling this way, and we'd have force of friction pulling that way. Because something's got to hold this system in place. We want it to keep everything at rest. On block 2, we'd have gravity, we'd have tension, and that's it. And then on the M1, M2 system, we'd have gravity trying to pull block 2 in this direction, which I just took this block and pulled it up here to say that M2G is trying to pull that way. We'd have friction acting against that on M1. And then we'd have gravity acting on M1, and we'd have normal force acting on M1. Okay. In all these situations, we want this system to stay at rest. So there's a bunch of different ways you can do this. I'll show all the ones we've got. I'm actually going to start with these 2 systems. Okay. So my first part, I'll do my work in a different color. My first part would be to just take a look at this system and say, actually, let's start with this system, and say that the net force acting on this system, I want to be M1 times A, and I want that to equal 0, because I don't want this system accelerating. My goal is to keep the whole system at rest. That means that tension minus friction has to equal 0, so the tension has to equal the force of friction. Okay, and that force of friction, it's going to be static friction. And since I'm saying, how big does mu have to be to keep this thing at rest, what I'm really saying is, what's the smallest I can make mu and keep this system at rest? As in the case where I am maximizing my static friction. So I'm going to set my friction equal to mu static times normal force, because my question is really saying, again, how small can I make this mu and still keep everybody at rest? All right, well, this is all lovely and wonderful. I can figure out how big that normal force is just by saying, in the vertical direction, I want net force in the y direction on this block, or to equal m1 times acceleration in the y direction, and I want that to be 0. I don't want m1 accelerating anywhere, which means normal force has to equal m1g. So I can plug in for that and say that tension is equal to mu static times m1g. The problem is that I'm stuck right here. I can't get this static coefficient of friction unless I know tension. But I've got other blocks I can deal with. So let's jump over here and deal with this block. On this block, I can say that the net force is equal to mass 2 times its acceleration, and I want that to equal 0. And on that block, I have tension acting up and m2g pulling down, and that has to equal 0. So this tells me that the tension has to equal m2 times g. That's a huge m2, I guess. All right, with that information, now that I know tension is equal to m2 times g, I can take that and plug in here and do some more nifty math. So now I can say this tension, instead of leaving it as tension, I can say it's equal to m2g. That equals mu static times m1g. The g's can cancel, and I'd get that mu static is just the ratio of those 2 masses, m2 over m1, which is 5 kilograms over 10 kilograms, which is just 0.5. So if mu static is 0.5 or bigger, this thing's going to stay at rest. Okay, the second part is, what's the tension have to be in this case? Well, I actually solved that part first. That tension has to equal m2 times g. m2 is 5 kilograms. G is 10 meters per second squared. So the tension has to be 50 newtons. Okay, so that's where we got that guy. All right, that is example 2, case 2. So hope that helps.